Welcome back. We're continuing to talk about reflected light. So we're on page 92 of your book. Reflection of light. When you look at a pane of glass, you sometimes can see an image of yourself. Light bounces off you, strikes the glass, and bounces back to your eye. Think about a calm lake like the one on the right. You can see the reflection of the trees on the other side of the lake. This is how the mirror bounced the light in the lab from yesterday, mirrored view. Recall that the bouncing of a wave off of a surface is called reflection. Suppose you toss a tennis ball against a wall. If you throw the ball straight toward the wall, it will bounce straight back at you. Where on the wall would you throw the ball so that your friend standing to your left could catch it? You might throw it toward a point on the wall about halfway between you and your friend. Law of reflection. Like the tennis ball, light behaves in predictable ways when it reflects. Recall that light moves in straight lines. These lines of light are represented in a model as straight arrows called rays. Scientists often use this model to trace the path of light. The rays in the ray diagram on the bottom right, which is right here, show how light reflects. An imaginary measuring line perpendicular to the reflecting surface is called the normal. Okay, you see how it comes in perpendicular to the surface, and it's always 90 degrees. That's what perpendicular is, if you remember from math. And the light ray moving toward the surface is called the incident ray. The light ray moving away from the surface is called the reflected ray. Notice the angle formed where the incident ray meets the normal. This is the angle of incidence right there. A reflected ray forms an identical angle on the other side of the normal. This angle is the angle of reflection. According to the law of reflection, when a wave is reflected from a surface, the angle of reflection is equal. I want to highlight that word, equal. Equal to the angle of incidence. So this angle is going to be equal to this angle. Very important. Okay, I'm going to move over here to images. Images. When you look in a mirror, it looks like you could touch the image in the mirror. When you look at ray diagrams, think about what you would see if the rays reflected into your eyes. Now remember, your brain only perceives where the rays appear to come from and not their actual paths. Look at the figure to the right. The object's in front of the mirror, but you see the image of the object behind the mirror. A virtual image is an image of an object that your brain perceives to be in a place where the object is not. Objects seen in a plane or flat mirror are called virtual images. So here's where the toothbrush actually is, because you are able to see it because it's reflecting off a mirror, okay? But your brain actually sees it over here. But that can't be real because that's behind the mirror. It's not really behind the mirror, okay, where you would normally be seeing it. The light is actually being reflected off the mirror and you're holding the toothbrush in front of you. That's called a virtual image. All right, what I'd like you to do is you can continue on to the 3D thinking down below, which just takes what we've just read. And I'd like you to, on this picture right here, or if you're in the computer, you need to go in and label this picture in McGraw Hill. The things you're going to use to label is the word normal, incident ray, reflected ray, angle of incidence, angle of reflection. Okay? So label those on this model right here. Okay? And then you want to go back and also you can use this image right here to go to your foldable. Yep, your foldable. Hopefully you still have this. And we're gonna go to a new flap called Law of Reflection. And we're gonna label it flat surface, curved surface, and uneven surface. So I'm gonna open that up, and there's gonna be boxes split into 3 sections for smooth or flat surface, curved, a smooth curved surface, and a rough surface. We want to make sure that we highlight the fact that light moves in straight lines. You do want to write the law of reflection. I actually am going to move it over here. If you go into the slideshow that I've attached, I've made this exact same flap into a slide. So you can copy that slide if you like. And I've just taken this picture right here and I've put it in your notes under smooth, flat surface for the law of reflection, okay? As we keep our notes handy dandy. The last thing we'll need to do is we're gonna go back to our CER and put in some information for evidence A. So I'm gonna turn back to page 88 for evidence A. Here we go. So, what evidence have you just discovered to explain how light reflects off a plane mirror? Plane mirror means flat, smooth, flat surface. So light rays that strike a plane mirror reflect. You tell me how they reflect. How do they reflect? Think about the angle of incidence and the angle of reflection. So a light ray that strikes a reflective surface in an animal's eye. There is a reflective surface in an animal's eye. How can that light be reflecting back to you? Okay, these are probably going to be the same answer. So think about how the light ray reflects off of a mirror. And so therefore, how is it going to reflect off of an animal's eye?